Hi guys, here's the video going over 10.4 Hyperbolas Day 2. So after you are done watching this video, you should be able to write the equation of a hyperbola. So in order to write the equation for a hyperbola, we do need to have an understanding of the different pieces that come from the graph of a hyperbola. So I'm going to start by listing out what A, B, and C represent in the context of hyperbolas. So A is the distance from, I spelled distance wrong, distance from your center to one of your vertices for the hyperbola. B is half the length of the conjugate axis. And C is the distance from your center to a focus, or your two foci when we're talking about hyperbolas. Now, when we are looking at hyperbolas, there's two standard form equations. You could have x minus h quantity squared, y minus k quantity squared equals 1. That's definitely not supposed to be a plus, that should be a minus. And that's a squared, b squared on the bottom. And then, so that equation is for hyperbolas that open to the left or to the right. And then we also have y minus k squared minus x minus h squared equals 1. A squared and b squared on the bottom. And then that'll be for parabolas, or sorry, not parabolas, hyperbolas that open up and down. So we'll make a note. This is for hyperbolas. I can't speak. Hyperbolas, left and right. And then if your y is first, those are hyperbolas that open up and down. Okay, here we go. So if I look at letter A, I have my vertices at 0, -7, and 0, 7. So I can see that my y coordinates are changing. So that means for this one, I have hyperbolas that open up and down, which means when I select my equation, I'm going to use the one with y first. Now I need to find my center because my center is h and k. So I need to figure out what's right in the middle of 0, -7 and 0, +7, and that's the origin, 0, 0. Now A is the distance from your center to one of your vertices. So going from 0, 0 to 0, -7 is 7 units. B is half the length of the conjugate axis. So if the conjugate axis is 10 units, that makes B 5. And now I can write my equation. So I have, let's see, so I have y minus k first. There's my h and my k. So y minus 0 quantity squared minus x minus 0 quantity squared equals 1. And then with hyperbolas, a squared is always first and b squared is always second. So what matters is whether your x or your y comes first. And the way that you determine that is by looking at the direction of your hyperbolas. Up and down means y is coming first. Left and right means x is coming first. All right, letter B. So I'm going to look again at my vertices. I'm going to look at the variables that are different, or coordinates that are different. In this case, my x coordinates are different. So that means I'm going to have hyperbolas that open left and right. So I'm going to find my center. So my center needs to be right in the middle of -2 and 4. So -2 and 4 are 6 units away from each other. So that means the center is going to be 3 units away from both of those. So that puts me at 1, -3. So A is the distance from your center to one of your vertices, which is going to be 3 units. C is the distance from your center to a foci, or a focus. So I'm going from 1 to -5, which is 6 units. I could also go from 1 to 7 over here, and that would also give me the 6 units. And now that I have A and C, I can go ahead and use that to solve for B. I have a formula for the foci for hyperbolas. It is c squared equals a squared plus b squared. It's Pythagorean theorem. So I have 36 equals 9 plus b squared. I'm going to subtract 9 from both sides, and I get b squared equals 27. Now, I'm not going to bother taking the square root of 27 because you're going to square it anyway, because that is what's on the bottom of your equations. So this was hyperbolas that open left and right, so that means my h is going to come first. So I have x minus h, there's my h and my k. So x minus 1 quantity squared minus y plus 3 quantity squared equals 1. A squared is always first for hyperbolas, and b squared is second. All right, let's do another one. So this one, you are given the graph, and it's very easy to see from the graph that your hyperbolas are opening left and right. You can find the center, because it's right in the middle. So your center is at 0, 0. And what you're given is you're given your vertices, as well as the points inside your hyperbolas, and those are the foci. So A is the distance from your center to one of your vertices. So that's so 0, 0 to 5, 0 is 5 units. C is the distance from your center to one of your foci. So that distance is going from 0, 0 to negative square root of 41. So that distance is going to be the square root of 41. And then, of course, since I have A and C, I have to use the formula for the foci to be able to solve for B. So it's A squared plus B squared. So I have square root of 41 squared is just going to give me 41 equals not 36, 25 plus B squared. I'm going to subtract 25 from both sides, and that gives me 16 equals B squared. All right, so since I have hyperbolas that are opening left and right, that means my x comes first. So I have x minus 0 quantity squared, y minus 0 quantity squared equals 1. And you're more than welcome to just write that as x squared minus y squared. But I have to show you all the pieces. And then for hyperbolas, a squared comes first, b squared comes second. And there is your equation in standard form. The next thing we're going to look at is identifying conic sections just based off of their equations. So we're not going to actually change each of the equations into standard form to identify the conic because that would take way too much work. Instead, what we're going to do is we are going to compare your x squares and your y squares. So all of these pieces of information that's written over here is comparing your x squared and your y squared. So for parabolas, your x squared or y squared, it says a equals 0 or c equals 0, but not both. So what that means is you can have an x squared or a y squared, but not both. It's one or the other. For circles, a equals c, which means your coefficients in front of x squared and y squared have to be the same. So for example, like 2x squared and 2y squared, or negative 3x squared and negative 3y squared. They have to be exactly the same for it to be a circle. For ellipses, they have the same sign, but a cannot equal c. So for example, you could have x squared and 3y squared. So they have to either both be positive or they can both be negative. But again, it can't have the same coefficients, just the same signs. And then for hyperbolas, they need to have opposite signs. So you could have a positive 3x squared with a negative 3y squared. All we have for hyperbolas is opposite signs. The numbers, the coefficients can be the same for hyperbolas. They cannot be the same for ellipses. Okay, so what I'm looking for is my x squares and my y squares. So I have 3y squared minus x squared, and I have my a and c being opposite signs. So this one is a hyperbola. For letter B, I have 2x squared and 2y squared. So my a and c are the same, and that creates a circle. I did not spell circle right. That's embarrassing. Circle. And then for letter C, I only have a y squared. I don't actually have an x squared, which makes that a parabola. And process of elimination would tell you that letter D is an ellipse, but let's double check. I have 4x squared, 1y squared. They are the same sign, and my coefficients are different. So that makes that equation represent an ellipse. All right, so that is how you identify equations of conic sections.